students of LS and GS in the BIS school. In this video, I am going to explain the last chapter, which is about stimulated nuclear reaction. Objective: define the stimulated nuclear reaction, define fission, explain the mechanism of fission nuclear reaction, define the chain fission, define fusion, indicates the advantage and disadvantage of fission and diffusion reaction, calculates the absorbed dose. First of all, stimulated nuclear reaction. Stimulated or provoked nuclear reaction is a nuclear reaction that cannot be activated by itself. It needs an external intervention in order to take place. This means that provoked nuclear reaction, it is different from radioactive. In the radioactive nuclear reaction, a nuclei was unstable by itself. It decomposes into a more stable one with the emission of radioactive radiation. Why? In the provoked nuclear reaction, this nuclear reaction cannot be activated by itself. It must combine with another one, or we must bombard it by a certain particle. Types of provoked nuclear reaction. First of all, fission nuclear reaction. Second, fusion nuclear reaction. Laws of conservation. Last, like what we said in the last chapter, in any nuclear reaction we have conservation of atomic mass. Sum of A of the reactant is equal to the sum of A atomic mass of the product. Also, conservation of atomic number, sum of the atomic number of the reactant is equal to the sum of the atomic number of the product. Also, we have conservation of total energy. This means that the total energy of the reactant is equal to the total energy of the product. This chapter, like what we said in the last chapter, we have three conservation. First of all, conservation of atomic mass, conservation of atomic number, and conservation of total energy. Liberated energy. Also, like chapter 19, mass defect, it is the difference between mass of the reactant and the mass of the product. Delta M equal mass reactant minus mass product. Also, the liberated energy by one nuclei E liberated equal delta M times C square, where delta M is the mass defect, C is the speed of light in vacuum, and E liberated is the liberated energy by one nuclei. Also, the liberated energy is equal to the kinetic energy of the product Z plus energy of the gamma rays. Nuclear fission. Nuclear fission, it is the first kind of stimulated nuclear reaction. It is a stimulated or provoked nuclear reaction in which a heavy nuclei is divided into two lighter nuclei after being bombarded by a small particle, usually neutron. For example, uranium 92-235 is bombarded by a neutron, gives two fragments and a neutron. Also, the second one and the third example. Look here. We have in the product two substances. While in the chapter of spontaneous radioactive, we have in the product only one substance. So here we have in the reactant two substances. In the previous chapter, we have only in the reactant one substance. Uranium is called the target A neutron is called the projectile, and the products are called the fragments. Condition of fission. We have only one condition for fission. The thermal neutron must be very slow of kinetic energy 0.02 electron volt. Chain fission. Chain fission is a nuclear fission which continues by itself. A chain fission is called a fission reaction. Is called chain fission reaction when we have as the product at least two neutrons, like we have in this equation. We have in the product 3 or 4 neutrons. When we have in the product more than 2 neutrons, we call this fission reaction a chain fission. Fissionable or fissional nucleus is the one that undergoes fission when bombarded by a smaller neutron. Here, uranium is called fissionable or fission. Nuclear second type of the stimulated nuclear reaction is the nuclear fusion. Nuclear fusion, it is a stimulated nuclear reaction by which two or more light nuclei combine together to form a heavier one. For example, proton plus proton gives the deuterium plus positron. Also, also proton plus deuterium gives tritium. We have two light nuclei combined to form a heavier one, while in fission we have a heavy nuclei bombarded by a neutron decomposed into two smaller. Here, two small combine to form a heavier one. Conditions of a nuclear reaction, of nuclear fusion. First of all, the kinetic energy of the nuclear fusion must be of 0. mega electron volt in order to overcome the repulsive forces between the two nuclei that are positively charged. Here, in fusion, we must have a very large kinetic energy, 0.1 mega electron volt. Also, the temperature must be 10 to power 8 Kelvin. So it is not controlled yet. It takes place only at the sun. Here we do not have a, generator that function according to the nuclear fusion. Advantage and disadvantage of fission and diffusion. Fusion has more advantages over fission because, first of all, for equal masses, fusion yields more energy than fission. Energy given by fusion is bigger than energy given by fission. Also, hydrogen is abundant in nature and cheaper than uranium. Fusion produces very small amount of radioactive nuclear waste while fission produces a nuclear waste. Fission has one advantage than fusion since the released energy of fission can be controlled and used as in a nuclear power station while fusion is not controlled yet. Absorb dose. Absorb dose, it is the energy received per unit mass of living organism. The formula absorbed dose is equal energy absorbed by the body in joules divided by the mass of the body in kilogram. Efficiency and total energy. Efficiency, it is the useful energy or electric energy divided by the total energy. We may also say that efficiency is the useful power or electric power divided by the total power. Note here that the total energy E total is N times E liberated, where N is the total number of nuclei and E liberated is the energy liberated by one nuclei. Also, we know that, remember that energy, it is the power times the time. New formula between this chapter and the last chapter, P equal A times E liberated power equal activity times energy liberated by one nuclei. Thank you.